course. Selecting A. Okay, so let's get started. Before I start, do you have any questions? Do you want to ask me anything about the material or otherwise? Okay, I can't hear you, but I'll assume that you have no questions. Can you hear me? So just tell me, can you hear me?
Yes, doctor.
Yes, doctor.
Yes, doctor,
Okay.
thank you.
Okay. So today I want to introduce these two, if you like, forms of matrices. So remember that we have so far introduced what we call the augmented matrix, which is a way to represent a system of equations, of linear equations in unknowns, right? And the matrix, just to remind you, is a way to encode the equations, the coefficients of the equations, and the right-hand side. So, for example, just to get you started now, if you have a matrix like this, like the one that you see here, this one here, right? So this is telling you that we have three equations. You see, each row is an equation. And there are three unknowns because you see the coefficient matrix has three columns, right? And the first equation reads x plus 3y plus 6z equals 25. Then the second equation is 2x plus 7y plus 14z equal to 58. And the last equation is 2y plus 5z equal to 19. So we can always translate a matrix given in this form into a system of linear equations, and vice versa. If we are given a system of linear equations, we can always represent it in the form of a matrix, right? And now we said last time that we can always, if you like, manipulate this matrix in a way as to make it easier to solve the system of equations. In particular, just to remind you, the operations that are defined on these matrices are the following. First, you can switch the order of any two rows. For example, you can interchange let's say, the top row and the bottom row, right? You can multiply any row by any number, non-zero number, okay? And then you can multiply a row by a number and add it to another row and replace the row by that one, okay? So we have seen this, and these are called usually elementary operations or just row operations on the matrices. Today, I want to use these operations, the elementary operations, which we have defined and we have already practiced earlier, okay, to reduce the matrix, the augmented matrix, into a very simple form, which will make it very easy to solve the system of equations at hand, okay? And these forms are usually called the row-echelon form and the reduced row-echelon form, okay? So these are the names are here, you can see them. So the row-echelon form, and the second one is called the reduced row-echelon form. So the idea is this. Given a system, we know how to write down the augmented matrix. And now what we want to do is to apply these elementary row operations in order to bring this matrix into a very simple form. Usually it's, I mean, we would like it to be in the reduced row echelon form, okay? It takes some work to get it into the reduced row echelon form, but in doing so, you have to pass first by the row echelon form. So if you want to get to the reduced row echelon form, first you have to take the matrix to the row echelon form, and then from there you can reduce it further to what we call the reduced row echelon form. So today I want to define these terms to tell you what these forms are, the row echelon form and the reduced row echelon form, and see a few examples. Okay, and hopefully I will be able to show you why is it useful to reduce a matrix, an augmented matrix, into a row echelon form or the reduced row echelon form. Okay, but now before I do so, let me just define these terms. So what is a row echelon form and what is a reduced row echelon form? So I'll start with the row echelon form because it is the easier one. Okay, and once we know what the row echelon form, it will take just one step further to get to the reduced row echelon form. Okay, so what is a row echelon form? First, for an augmented matrix to be in a row echelon form, it should satisfy three conditions. Okay, so these are the three conditions. First, if there is a row which is made of zeros, all of it is made of zeros, okay, then this row has to appear at the very bottom of the matrix. It has to be the last one, okay? Now, of course, you may have more than one row. You may have two rows made of zeros, or maybe three rows, or one row. It depends, okay? So all these rows have to be at the very end of the matrix. They have to appear at the bottom, okay? And of course, we can achieve this very easily. All we have to do is just switch the rows, right? So if we have it, let's say, in the second row, let's say we have the second row, all of it is zeros, right? Then we can switch it with the third one, so we can bring it down, okay? So I think here there are a few examples. So if I look at this matrix here, you see this matrix here, then you see this row here is made all of zeros, right? And it is in the so it is at the very end. You see, it is in the bottom, okay, at the bottom of the matrix, right? Now let's say that this row appeared somewhere here instead. Let's say it was here. It was the third one, or the fourth one, in fact. So here we had 0, 0, 0, 0, right? And this one here was, let's say, 1 instead. Then it won't be in the row echelon form, okay? So here's an example. Here you see the top row is made of zeros, right? So this top row is made of zeros, right? See it here? Then because it's appearing at the very top, right? So it is not in row echelon form. But now this can be amended very easily. It can be, we can easily correct for that. All we have to do is just switch this row with the other rows. For example, I can switch it with the fourth one. So take this row, which is here, and bring it down, put it in. Do you know what? Let me just pick the annotation tool, because it's not easy to just highlight the text here. So give me a moment to pick the annotation tool. I think I need to minimize all this. Yeah. Okay. Okay, so back to here. So as I said, the problem with this with this matrix is not in row echelon form because of this row. You see, this row is made of zeros, and it's appearing at the top. So it can be the case. What I have to do here in order to make it into the row echelon form, I simply need to switch it with, let's say, the fourth one. So I need to bring it down here, right? And bring this one to the top instead, let's say, okay? But certainly, so what I'm trying to tell you, and this is the first condition that you need to observe, okay, whenever you are trying to bring a matrix into the row echelon form, that if you have a row which is made of zero completely, all of the entries are zero, right? Then this row has to be at the very end of the matrix, or at the very bottom of the matrix, okay? And you may have more than one. You may have two of them, but no matter how many you have, they should all appear at the very end of the matrix, at the bottom, okay? So this is the first condition. The first condition, and this is very easy. In fact, it's the easiest condition, okay? Yeah, okay, so all the zeros have to appear at the very end. Okay, now, let's agree now on the following terminology. An entry is said to be a leading entry, and this is the term here, okay? So the entry is just a number in the matrix, right? So we call it a leading entry, okay, in a row, in a given row, if it is a non-zero entry, if it's the first non-zero entry in the row, okay? So, of course, we always read from left to right. You always go from left to right. So you take a row, right? And you go from left to right. And the first entry that you get, which is not zero, right? Then you call it the leading entry of that row, okay? So let me just try to show you this on an example. So what is the leading entry of this row here? What is the leading entry of this row? The leading entry here is obviously 1, right? Because the first number that you encounter, which is not 0 in this row, is 1, okay? Okay, what is the leading entry in this row? The leading entry in this one here. And as you go, this one is 0, so you don't count it, right? Then the second one is, which is not 0, this is it, right? And the leading entry in this case is 1, right? For example, if we look here, so what is the leading entry in this row? Okay, the leading entry in this row is just 7, the first number, which is not 0. The leading entry in this row here, obviously it is this number 2. This is a leading entry. So it is in a row, we call the entry the leading entry if it is a non-zero entry. Of course, so starting the first non-zero entry starting from the left. So we start reading from the left as we usually do, right? And the first number that we encounter, which is not 0, we call it the leading entry of that row. Okay, and now what is the second condition? So the second condition has to do with the leading entry, and let's read it carefully. Okay, the leading entry of a row is in a column to the right of the leading entries of any row above it. So this means that, you see, for example, here, if I look at this one here, okay, so the leading entry in this row, you see, and which is this number 1, okay, is to the right, of the leading entry of the row above it. Okay, so this example satisfies the condition. You see. Okay, if we look here, for example, let's look at this one. The leading entry in this row, you see, is not to the right of the leading entry in the row above it. Okay, but it has to be to the right. To be in row echelon form, the leading entry of a row has to be to the right of a leading entry of the leading entry of a row above it. Okay, this is very important. I mean, to be in row echelon form. Simply stated, when you look at the matrix in the row echelon form, it should look like a staircase. You remember the staircase يعني الدرج. بتكون مثل الدرج شكلها يعني بيكون هيك. Then the leading entry of the second row has to be to the right. Then the leading entry of the next row has to be also to the right, and so on. Okay. So when you look at a matrix which is already in row echelon form, right, all the non-zero leading entries, okay, of the rows below have to be to the right to the leading entries of the row above. Okay, so this is the second condition. This is the second condition. Okay, and finally, the leading entry of every row has to be equal to 1. Okay. So when a matrix has all its leading entries equal to 1, and this is something which you can achieve easily, now we shall see how, by dividing the row by a number, okay, then if all these leading entries are 1s, then we say that the matrix is in row echelon form. So just to summarize it, we have 3 conditions to be met, okay? So all the rows which are made completely of zeros, they have to appear at the very bottom of the matrix. Second, all the leading entries of a row have to be to the right of the leading entries of any row above it. Okay? And finally, the leading entry of any row has to be equal to 1. Okay? If the matrix satisfies all these conditions, then we say it is in row echelon form. So the row echelon form, and it means, so this word echelon, okay, echelon, it means a staircase, daraja, okay? So it's made out of rows which look like the staircase, okay? So the rows look like the staircase, and the form is just the shape of the matrix. So the matrix has to be in row echelon form. So let's just look at a few examples, okay? So this matrix, as we said, it's obviously not in row echelon form. Right? And the reason here is because this top row is made of zeros, and we said that any row which is made of zeros has to be at the very bottom. So this is not true. So now, if I simply switch this row, let's say with the third one, or what I'm going to do is just, you know what, I'm going to switch it with the second one, then with the third one, and then with the fourth one. So I will try to rewrite the matrix. Wait a bit, I did something wrong. Yeah, this is here. Do you know what? Let me try to do it in Jam. So in order to save it for later, so you can look at it later. Wait a bit. Again, I did something wrong. So I want to go to Jam. Okay, new Jam. Let me call it row echelon form. Row echelon form. We call the Jam row echelon form. So the matrix was, I wish I could copy this matrix, but I think I can't. Yeah, there is no way I can copy it. I don't know. So let me, okay, so 0, 0, 0, then 1, 2, 3, 3. Okay, so now I'm going to try to write it here. So this was our matrix. So we have 0, 0, 0. I think there were 4 zeros. Yes, 4 zeros. And here we have, do you know what? Let me just make them a little bit sparser. So zeros, zeros, zeros.
Then 1, 2, 3, 1, 2,
yeah,
3,
1,
3.
2, 3, and then what here? 3 come in?
3.
Yeah,
0,
okay.
1, 0, 2.
0, 1, 0, 2.
0,
Okay.
0, 0, 1.
0, 0, 0, 1.
And
Okay.
last one, kilo 0.
Yeah, okay, and the last one is 0, 0, 0, 0. Okay, so what I want to do now is just bring this top row, which is made of zeros completely, I want to bring it down to here. Okay, so what I'm going to do first is switch it with the second row. Okay, so this is how I'm going to write it. I will switch the first row R1, switch it, and I will indicate this way. Okay, so this means switch it with the second row. Okay. And we shall see now. And of course, we'll get now 1, 2, 3, 3 at the top. Okay. And then we'll get 0, 0, 0, 0, this one here. And then 0, 1, 0, 2. Okay. And then 0, 0, 0, 1. Okay. And then 0, 0, 0, 0. Okay. And then you do it once more. Now you switch it. You switch now the second row, right? With the third row. Now, this is obvious, right? So you continue now doing this. So you switch it now with the third row. Okay? And this will, of course, bring it one step down, right? One step further down. So it will be 1, 2, 3, 3. And now the top one is going to be now 0, 1, 0, 2, right? And then here now we'll have our row made of zeros, will appear here now. And the one below it now is going to be 0, 0, 0, 1. And then finally, this one, which we did not touch, it's just 0, 0, 0. Right? And one last change now is again to switch now the third row with the fourth one, right? To get now this matrix. Now we get 1, 2, 3, okay? 3. Right? And then we have 0, 1, 0, 2. Right? And then we have 0, 0, 1, and 0, 0, 0, 0. Right? And finally, this one, which we did not change, 0, 0. Okay. And now you see now these two rows, which have zeros, they appear at the very end. Okay. But now this is one condition. So now is our matrix here, is it in the row echelon form? Okay, so let's see. To be in the row echelon form, every leading entry in every row has to appear to the right of the leading entry in the row above, right? So here, these two rows have no leading entries. You see this row here, and this one here. I mean, these, let me just underline them in red. So this row and this row, they have no leading entries. Now this row has one, it's here, you see, and obviously it's a period, even bring it more to the right, right? That's it, it's the rightmost, right? So you can't do anything about this one. This one, its leading entry is this number, and it's appearing, as you can see, to the right of this entry here, right? Which is the leading entry of the top row. Yeah, okay, so this is fine. And of course, this one is leading entry because there is no row above it to compare to. Okay, so every leading entry has to be a 1, right? Every leading entry has to be a 1, and you see that all of them are 1s. So now this matrix is already in row echelon form.
دكتور بليز بس سؤال. كلهم مش كل الماتريكس بدها تكون 0 1 بس اخر واحد.
اول انتري بالرو يلي هو مش صفر بده يكون 1. يعني مثلا هون suppose that we had here a 2, let's say, suppose, then it won't be in row echelon form.
Okay. Thank you, doctor.
Yeah, so I'm not saying that every number has to be equal to 1. Not every number has to be equal to 1. I'm saying that every leading entry, يعني أول entry, which is not 0 in a row, this entry has to be equal to 1. For example, this number is not a 1, you see? This is a 2, and this one is not a 1, it's a 3. Okay, this is fine. The matrix is still in row echelon form because leading entry now, which means every entry which is not 0, okay, the first entry which is not 0 is a 1, then the matrix is in row echelon form. Okay, so let's take now another example. Yes.
هلا ما قلنا بده يكون كمان الليدنج انتري انه الابوف بده يكون تو ذا رايت او هيك شيء مثل الدرج. هلا هون بس اول تو روز هيك خلص بمجرد انه عندي تو روز بيزبطوا على هيدي الكونديشن، يعني انه هيدي الكونديشن صارت فيريفايد صح؟ ولا لازم كلهم؟
لا wait. I said انه بدهم they have to look like a staircase، بس الستاركيس مش ضروري يكونوا فيها كلهم مثل بعضهم، يعني ممكن يكون وحده كبيره وحده صغيره، مش مهم كيف بتكون، بس بدهم يكونوا هيك شكلهم، يعني ما فيك ترجع رجوع. You can't go back like this. You can go always to the right. اوكي بس مش مهم قد يعني العتبه اذا ما نسميها عتبه، يعني هيدي ستيب هون مش مهم قد هي wide or narrow, but it has to be always to the right, never to the left. Okay, let's take another example. The example I will take from again from the book. So look at this one here. Look at this one here, at this matrix. So what's wrong with this matrix? If we look, so here you see there is no row made of zeros. So the first condition is met because there's no such row. The problem here is
مش تحت بعض.
Say it again, please.
Leading entry. Yes.
Right. Yeah.
تحت بعضهم كمان.
The problem is in this leading entry. You see, the leading entry in the row has to be to the right, to the right of the leading entry in the row above it. And you see, the leading entry in the row above it is this number 2, right? And number 2. This is the leading entry in the row above it. So this leading entry here, the 4, should appear not here. It should appear here instead, right? To satisfy the condition. So this matrix is not in row echelon form. Okay. Now the question is, can we make it row echelon form? Let's see. Yeah, of course we can make it. So let's now copy it. If you can, please dictate me the matrix.
Okay. 1 2 3.
1 2 and the 3 here. Okay.
2 4 minus 6.
Yes.
4 0 7.
4 0 7. Okay. So what I'm going to do now, to make it into row echelon form, all I have to do is make this entry here. Let me underline it. This entry here, make it a 0. This one here. And of course, there are many ways in which you can make it a 0. For example, you could multiply the first row by -4. Remember the operations, these elementary operations. You can multiply the top row by -4. and one, okay? And I'm going to do this. So let's see, remember how we write it? And I want you to write them down when you are solving this in the exam in order to be able to correct for you the work or check your work. You need to tell me what you're doing. I can't simply guess by the shape of the matrix. So you need to write down what you're doing. And the way I do it is to do this, -4 multiplied by row 1 and add the result to row 3, right? And where do you place it? You place it in row 3. Okay? And let's see what we get then. So the first row, of course, will not change. And so will the second row. The second row also will stay unaltered, right? -6. What will happen to this one? This will become a 0. That's why we did it, right? We multiplied by -4. This will become -8, right? And this will become now, we multiplied by -4. So it became -12 and 7, so it's -5. Okay. Okay. Now we see here. So the leading entry now, this one now, the leading entry now is -8, right? This is it. Now this is the leading entry. You see, the leading entry now is appearing to the right of the leading entry in the row above it, because here the leading entry is this one, this 2. You see. So now it's not yet in row echelon form, right? It's not yet in row echelon form because why? Because this leading entry here, you see this leading entry is still appearing under the leading entry of the top row, right? So what I need to do now is to get this one, to make this one 0, right? And we can do this.
2,
right?
Row 1 times -2 plus row 2.
Yeah, so I'm going to multiply now the second row by -2, right? Sorry, the first row by -2, and add it to the second row, right? Plus the second row, and of course place the result in the second row. Place it in the second row. Okay, let me now erase. Okay, I can't erase this, so I'm going to go here. So I will write the result here. So 1, 2, 3. This will stay unchanged. And this will become now, so we are doing now -2, right? So now you see that this is going to give me 0, 0, right? And here I will get -12, right? -12. And that's this one now 0, -8, and -5. Okay. And now, okay, what do you think? Is it in row echelon form? If we keep it like this?
No, بدنا نعمل switch الثاني والثالث.
Right, absolutely right. So there is a problem that this leading entry, you see, is up to the left of the leading entry in the row above. You see, so this row here has a leading entry here, and the leading entry in the row below is appearing to the left. So if you want to draw now a staircase, your staircase will go like this, and then will come back, right? It will come back like so, which is not what we want, right? We want to go always to the right, right? So now we need to switch, as you said, right? We need to switch now the second row and the third row, right? And this is how we indicate this. Switch it. The third row.
Doctor, it's not necessary to be 1. It could be any number, right?
Hala, we'll get to it. Wait, we are not done yet. But certainly in this form, it's not in row echelon form yet, right? If I leave it like this, it's not in row echelon form. So let me continue now. Okay, and now we have this. So now as we switch, this will go up here, -8 and -5, and this row will go down here. Okay.
Now we divide by -8.
Right. Now, yeah, so now that's not yet in row echelon form, because you see, to be in row echelon form, the last condition, if you remember, says every leading entry has to be a 1, right? So here, in the first row, it is a 1, but in the second row, it's not a 1, it's -. Right? So how can you make the -8 into a 1? And of course, you need to divide by -8, right? So here, what I'm going to do now is divide. So if you like, multiply the second row by -1/8, right? Just multiply it by this, okay? And then in that case, we get 1, 2, 3, Okay, 0, 1, 5 over 8, right? And this one now will not change. Now you see, okay, now you can go on if you want, but you already see that this system is inconsistent. And of course, if you are solving a system of equations, I mean, you would stop here, right? You would reach to this step here, and you would see that there are 2 zeros here and negative 12 here. It's impossible. The system is inconsistent. It has no solutions. So in fact, it makes no sense to go further, right? Because you already see that the system is inconsistent. Okay, but here, of course, I'm trying to illustrate the idea of the row echelon form. Okay? So how do you transform a matrix from any form to a row echelon form? Yeah. Any questions? Do you have any questions?
دكتور مش هلا لازم نقسم ال -12 على -12.
Yeah, if you want to, but as I said already, there is no need to do so because the system is inconsistent, and what you are looking for is a solution, right? And you already see that there is no solution, so it doesn't make any sense to. If this -12 was here, let's say instead, right? Then yeah, I would do what you said. But since I see that the system is inconsistent, it makes no sense to proceed further with this row echelon form. It's already inconsistent. Yeah, but if you want to be... Yeah.
فينا إنه نضرب ال second row ونزيد على third ولا بس الأولى؟
Yeah, we can. Yeah, of course. If you want, let's say, if you want to get a 0 here, let's say, let me just try to. So if I want to make this a 0, right? I could have used the second row instead of the first. Right? I could. Yeah. Anything. You can do anything which is allowed. So any of these operations, the elementary operations, right? You can do any of them with any row you want, okay, in order to achieve a 0. Anything you want.
Doctor, what is the purpose of row echelon form? What
Yeah,
can we
okay.
use it?
This is very good. I will get to the purpose, but I can tell you now, and I will illustrate it later, is to get the system into the simplest possible form so we can see the solution right away. So you just look at the matrix and you can read the solution directly from the matrix. Okay, but we'll get there. We'll get there. So we are not yet there. Okay, so we'll get there. Okay? But I want now to make clear that this idea is, I want to make sure just the idea is clear. Okay? Is this idea clear? The row echelon form.
Doctor, I have a question.
Yes.
We can conclude that if the matrix is already not row echelon form, it can be transformed, because in this way we try to transform and we reach the same solution.
Say it again. We tried to do what initially?
We tried to transform the matrix into a row echelon form,
right?
But it didn't work. So it can be transformed.
Where did you see that it didn't work?
Because at the end, we still have 0, 0, but -12.
Oh, yeah, the system is inconsistent, but we got the matrix. So the matrix is, if I divide this row by -12, so if I go one more step, let me do it. If I take now row 3, right, and divide it by -12, right, then my system will be now in row echelon form. Do you agree? I did not say that the system has to be consistent. I said that the matrix will be in row echelon form. So now 5 over 8, right? And this will be 0, 0, 1. Okay. Now, tell me, please, according to our definition, is this matrix in row echelon form? Can you hear me?
Yes, it is.
Yeah, but it's inconsistent, right? But I'm not saying that the row echelon form has to be consistent. I just want to get the matrix to row echelon form, okay? And then you see the form, when you have it already in row echelon form and later in reduced row echelon form, you will be able to tell whether the system is consistent or is not consistent. And in the former case, when it is consistent, you will be able to find the solution immediately.
ايه دكتور مزبوط، بس نحن هون عنا بهيدي الحالة دغري من أول الماتريكس بينت إنه not consistent، فدغري بنحطها بالإكزام لبعدين.
هلا أنا it depends on the question. If the question is to solve the system, solve it, find the solution, then yes. then yes. But sometimes you may get a question to reduce the matrix into row echelon form. So you don't care about the solution, you don't care about the system, you just deal with the matrix. Just imagine that you have a matrix and try to manipulate the rows in the matrix so as to get it into row echelon form at the end. Okay, any questions? Okay. Let me tell you now about the reduced row echelon form. And in fact, it takes only one step now to go from the row echelon form to the reduced row echelon form. And the condition, the last condition, which is the difference between the row echelon form and the reduced row echelon. So this is the row echelon form here. See, this is the row echelon form. And in the reduced row echelon form, there is one more condition, right? One more condition. And this is very simple. It says that all the entries, okay, above a leading entry and below a leading entry in a matrix, right, they have to be all zeros. They have to be all zeros, okay? So this means that, for example, if I go back to our example here, okay, to our example here, so now we have already our matrix in row echelon form. It is in row echelon form, but it's not reduced row echelon form. Because to be in reduced row echelon form, all the entries which are below the leading entry, like this one, say, let me turn to red here. Okay, so this is a leading entry here, right? So all the leading entries below it and above it. So this one also has to be 0. This one also has to be 0, which is not here, you see? And in this one here, this has to be 0 and this has to be 0, you see? So whenever you have a leading entry in a row, everything which is above it and below it, okay, has to be 0. Then in that case, the matrix is said to be in reduced row echelon form. So there is this difference, reduced row echelon form. Okay, is it clear?
Yes, doctor.
Okay, now how can we, yeah, do you have a question?
I said clear.
Okay, so how can we change this matrix into reduced row echelon form? So I want to make this entry 0, you see, and I want to make these two entries here 0 too. Okay, so look what I'm going to do. Now to continue our transformation, so what I'm going to do now, maybe this is a little bit too long because I won't leave space here for the, so what I'm going to do is, first I will make this number into a 0, this number here, and I can achieve this by simply